All right, today we're going to take a look at 6-5 operations with radicals expressions. Some of this will look very familiar as we have been working with radicals up to this point. Some of this will be new, and probably the most challenging part of the question or part of the day is going to be dividing those radical expressions. We've rationalized with square roots in the past, but now we're obviously going to do that process with larger index roots, which is where usually the challenge comes into place. All right, but I'll point that out more when we get to that point. So simplifying radicals, product property, you guys should know that the square root of 2 and the square root of 8, if I multiply them together, that's the same as the square root of 16. Okay, the same is true with different index roots. So if we have the cube root of 3 and the cube root of 9, that's going to be the same root as the cube root of 27 or 3. So just kind of keep that in mind as we're going through things. What's outside stays outside, what's inside stays inside. So if you have something like 2 times the cube root of 3 and 4 times the cube root of 9, okay, what you're going to end up doing is keeping what's outside outside, what's inside stays inside, and then you simplify down to get your answer of 20. Okay, this is kind of an aside over here, but as you simplify radicals, if something's on the outside, it stays on the outside. If something's on the inside, it stays on the inside. And that would be unless you can simplify it down like we did here. Okay, so looking at example 1, here we go. We know that 12, all right, thinking about this is a square root, even though the index is there. 12 is 4 times 3, and then I'm taking out groups of 2. So I can take out a 2. I can take out an x. I can take out 1y. And I can take out 2 z's, and I'm going to have 1 left over. And then I'm going to be left with a 3y z underneath. Again, it's that idea we're taking out groups of 2. 2 divided by 2 is 1, which is where the x came from. 3 divided by 2 is 1 with 1 left over. And then 5 divided by 2 is 2 with 1 left over. All right. Moving ahead to B, kind of thinking that same idea. We're thinking about perfect cube factors now. Our index is 3. So I have 27 and 2 is going to be 54. So the cube root of 27, we can take out, that's going to be a 3. All right. I can take out one group of 3 from the 8. 4 divided by 3 is 1, with 1 remaining. I can take out 2 groups of B. 7 divided by 3 is 2, with 1 remaining. So I'm going to take out 2 groups of B. And then what's under, or what stays there, is going to be that 2, the A, and the B. Okay. So we want to pull out perfect cubes. Anything that's not a perfect cube, we have to leave under the radical. Again, those problems should be very familiar. We've worked with very similar concepts up to this point. Okay, quotient properties are going to be a little different. Okay, if we have something like 1 divided by the square root of 3, we have to rationalize. All right, so we multiply the top and bottom by the square root of 3, and we wind up with root 3. Square root of 3 times the square root of 3 is square root of 9, which reduces to 3. Okay. This process is called rationalization. We want to get our radical out from underneath our denominator. The same is going to be true with other roots. Okay, so we just need to be kind of cautious as how things work. And there's a couple ways you can do this. You can either simplify what's under your radical first and then rationalize, or you can rationalize and simplify. If you rationalize then simplify, there is a small chance you might have to rationalize again. So that's why I always recommend simplifying what's under your radical first. Okay. Keep in mind, this is a square root. Okay. So this first problem is pretty straightforward. So we have the square root of a to the 9th over the square root of b to the 5th. Okay. All right. Kind of thinking about that. it looks like we could simplify, okay? Because these powers are larger. So I'm going to simplify that down. I can take out a to the 4th, and then I'm left with the square root of a on top. So with 9 and an index of 2, 9 divided by 2 is 4. A to the 4th comes out. I'm going to have 1a left over. Same on the bottom. My index is 2. So I'm going to take out a, not a, what are we doing? It should be a b. All right. So I'm going to take out a b squared, and I'm going to have 1b left over. All right. So at this stage, we need to rationalize. We can't leave a radical in our denominator. This one, again, is very straightforward because it's a square root. We've done it before. I need another square root of b to rationalize. And then we wind up with a to the 4th, square root of ab on top. And on the bottom, remember, the square root of b squared is just b. We wind up with b cubed. Okay? So square roots, we add another square root of b to get those to cancel out. Pretty straightforward as far as things go. Okay? This is going to be the more challenging problem of the day when we change the index of the root. Okay? So again, let's break it up first. So we have the 5th root on top. We have the 5th root on the bottom. Okay? I'm going to tell you right now, the tendency for students is to just copy this down. Okay? And do that on the top and bottom. All right? Because that's what you're familiar with, and that's what we've done with square roots. The only problem is we need groups of 5. Okay? And right now on the bottom, all I see is 2 y's, and I see a 4 times a 4. Okay? So I see 2 4s, or I see 4 2's. If you want to think of 4 as 2 squared. Okay? So I don't have groups of 5 right here. So all we've in essence done is change this to the 5th root of 16 y squared. 16 is not a 5th root. It doesn't simplify, right? And y squared doesn't simplify. So I still have that radical in my denominator. So this whole method does not work, okay? So what we need to think about, again, is the index, right? If I have a 5th root, I need groups of 5 in my denominator. So if we think about this, I have 2 squared and y to the 1st. Okay, so the question is, what is going to make this a group of 5 in my denominator? Well, I'm going to need 3 more 2's, and I'm going to need 4 more y's. All right, because now if I multiply those out, I would have 2 to the 5th under my radical, and I would have y to the 5th under my radical. What I do to the bottom, I must do to the top. All right. At this stage, you can then see on the bottom, we have the 5th roots of 2 to the 5th, y to the 5th. Up top, we have the 5th roots of 3 times 8, which is 24, y to the 4th. And then we can simplify the bottom, right? So what's the 5th root of 2 to the 5th and y to the 5th? Well, it's just 2, 1, okay? Again, the big thing is making sure you have groups of 5 on the bottom. It's got to match the index. If you had a 6th root, you'd need groups of 6. If it was a 4th root, you need groups of 4 on the bottom. Don't just copy what we had here like we did with square roots. That works because you just need groups of 2. So if you just copy it, you're going to have a group of 2. All right? When we change our index, it's going to make it a little higher, or a little more challenging. We have to come up with those groups of 5. All right. Simplifying radical expressions. There's kind of summary on the bottom. Make sure your index is as small as possible. Radicand contains no other factors as 1. Radicand contains no fractions, and no radicals appear in the denominator. This is kind of the big one. Do not leave radicals in your denominator, otherwise you will lose credits. All right. Continuing on to the last couple questions of the day. These ones are pretty straightforward. It's just kind of a summary of all those rules. So as we go through them, like I said, what's outside stays outside. So we're going to have a 24, and then we wind up with the square root of 16, c to the 4th, d to the 7th. All right, then we can figure out and take out what we can. Well, I can take out the square root of 16, which is 4, right? 4 times 24 is 96. I can take out a c squared. I can take out a d cubed, and I'd be left with 1d in it. All right. When we're adding radicals, right? Very similar to like terms. These are not like terms at this point. So I would encourage you to simplify roots when we can. I know 8 is 4 times 2, right? So I can simplify this down as 2 square root of 2. I know 50 is 25 and 2, so I could simplify that down to 5 root 2, which means I have 8 root 2 and 15 root 2. When I now can combine them, I wind up with 23 root 2. Remember, the only way you can combine radicals is if they're the same. If I had something like 3 root 5 plus 2 root 7, those are not the same. That would be your answer. You can't simplify this and say, you know what, you have 5 root 12. That is not how it works. Okay. Looking at the last 2 problems of the day, hopefully you kind of see this and you're like, you know what, I would probably FOIL that. And you are exactly right. So we'd multiply it out. 6 root 3 times 2 root 5. We're going to wind up with 12 root 15. Interesting. Something though. All right. Minus 10 root 5. There's a ghost in the room here. I'm scared. All right. And then we need minus 20 root 2 and 24 root 6. I think is the one I missed. Right? Minus 20 root 2 and 24 root 6. Notice all of our roots we cannot simplify, and none of them are the same. So we would have to leave our answer just like that. All right. These last ones are really straightforward. Okay. We've seen this in the past when we're dealing with complex numbers. All right. We want to multiply essentially by the conjugate. Okay. And I say conjugate just because we dealt with it in complex numbers. But whenever we have a radical and a 2-term expression in the bottom, we want to get rid of it. And the only way we know how to get rid of it is to use this idea. We're going to multiply it by the same thing with the different sign. So we wind up with 2 root 5 minus 2 on top. On the bottom, then we can FOIL. Okay? When we FOIL, we wind up with 5 plus the square root of 5 minus the square root of 5 minus 1. Notice those cancel, which is perfect. That's exactly what we wanted. That's exactly what we did with complex numbers as well. 5 minus 1 is 4. And then you just simplify. We'd wind up with, I could take a 2 out of each of those. So I have square root of 5 minus 1 over 2. You can leave your answer like that, or you can break it up into 2 separate parts. Well, that's kind of the big thing today. We're going to be simplifying radicals and performing operations with radicals. If you have any questions, again, as always, feel free to let me know. Chime into the live session or the discussion board. Otherwise, best of luck. Have a good day.